Good morning, all of you. Today we shall see Module 4, Session 9, Cloud Computing and Applications. In the last session, we discussed about Aneka MapReduce programming. The MapReduce programming implementation on Aneka Cloud. How Google MapReduce as well as Hadoop MapReduce concepts have been implemented in Aneka platform has been discussed, and we have seen programming abstractions wherein lot of interfaces, skeleton programs, class definitions for map function as well as reduce function also have been seen in the last hour. Today we shall continue our discussion with runtime support, because the program need to be executed for a distributed file system where large amount of data is streamed, and that will be fed to the MapReduce executors and schedulers. There will be multiple MapReduce executors. The file which is coming in a large scale need to be segregated or split into pieces, and these pieces need to be sent for execution of map and reduce functions. The job of scheduler will take care of scheduling the execution, sending files to these MapReduce executors, and once MapReduce output comes, these will be taken as intermediate files and it will be sent back to client. This was the concept we saw in the last hour. So here there must be some mechanism to execute these in a distributed environment. For that we should have a proper runtime execution or runtime support. In the runtime support for the execution of MapReduce jobs, we'll have the services like MapReduce execution service as well as MapReduce scheduling services. So job and task scheduling need to be done along with task execution. So let us see the first one, the scheduling architecture. MapReduce scheduling service architecture. In this, there will be an Aneka middleware, MapReduce application execution as well as MapReduce scheduling executions are shown in this picture. So MapReduce scheduler service has been shown like there are multiple functionalities for MapReduce scheduler, like uploading into the queue, initialization of queue, dispatching a queue. Suppose you have a failures in execution, that also need to be handled in the failure queue. Resubmission, if there is a failure, then the module need to be resubmitted for execution. And finally, the execution reports, which are all executors have completed their execution successfully, also need to be reported back. For all these things, the DFS implementation, data file system implementation will be there. As you know, the data size is more, data size is enormous, and it cannot be handled using a simple database management server or database management system. You should have a special implementation for data file systems. Remember, when you are handling such a big data, the MapReduce executors need to get the file data. How do we think about accessing a file when a file in the Unix environment? So you need to locate the file first, and then you need to access the content of the file. So in this case, in a distributed environment, the file comes in a stream manner. The file need to be read, the stream data need to be read. So you should have a mechanism to read the data. So retrieving the location of file and file chunks is very, very important. So we shall see that in the next coming pictures. MapReduce execution service architecture. Here, the MapReduce executions need to be handled with respect to multiple executors, which we have seen in the previous class also. There will be multiple executors. For these executors, using your priority queues, scheduler will schedule the job for execution. Once jobs are executed or scheduled for execution, this MapReduce executors will execute the job. Here MapReduce executor is there, MapReduce reducer task is there. So look at here, the reduce task will take up the reducing task, map task will take the mapping task. For this also, you need to have an execute manager, which will also having a command queue. So which command need to be executed, which will be handled with a command thread, as well as the job and task information will be here in this queue, and the reporting task will be done through reporting thread. So in the previous picture also, remember, all these are being taken as thread. As we know, if you are implementing threaded implementation, you are doing multitask environment, correct? So multitasking environment can be either asynchronous or asynchronous mode of execution, but here, because it's a threaded implementation and the proper dispatch queue will be there, resubmission queue will be there, failure queue will be there, as well as reporting queue will be there. So execution can be executed in an asynchronous mode. Remember, these executions will be done in the asynchronous mode of operation. Now, okay, so MapReduce execution service architecture you have understood. Here also DFS implementation is already there as the underlying architecture for handling data. Next we shall see how distributed file system will be handled through MapReduce programming. So here, as I told you, in the MapReduce implementation, files are coming in the stream manner. This data need to be read by the MapReduce programming model. Retrieving of files, retrieving of location is very, very important. These tasks need to be executed. When these files are transmitted from the client machine to the distributed architecture execution model, which is available elsewhere, the file should go in a proper format. When the files are going, file chunks are going to the execution model, it has got certain standards. So the executor in the distributed environment has to know from where the file need to be accessed. The location of the file should be known to the executor. Along with that, accessing the file means of a stream also need to be known. So let us see how the file goes in a proper manner, proper format, so that because the client and the executor should have proper communication of files. Otherwise, the file goes in one format and the executor wanted the file in a different format, then this will not work properly. So you need to have a proper mechanism to send the data. So on top of the lower level interfaces, the MapReduce programming model offers classes to read from and write to files in a sequential manner. These are the classes called sequential reader, sequential writer. So name is seq reader as well as seq writer. They provide sequential access for reading and writing key value pairs, and they expect a specific file format. So this has been shown in the previous figure. We shall see the depth of these file formats available in the file formats. So the Aneka MapReduce file is composed of a header used to identify the file and a sequence of record blocks, each storing key value pair. The header will be having 3 bytes magic number and 1 byte version number. The first 3 bytes represent the character sequence SEQ, and the 4th byte identifies the version of the file. Sequence of the file is shown in 3 bytes, and the 4th byte represents the version of the file. So there may be multiple versions of the file which can be transmitted also. The record block is composed of 8 bytes. The first 8 bytes are used to store 2 integers representing the length of the rest of the block and the length of the key section, which is immediately following. So if you look at the picture available in page number 8.37 in the regular textbook, the first block is having integer of 4 bytes, which shows the length of block. Another 4 bytes will be the length of key, then 1 byte for key byte array, and another one is continuously key byte array shown. Let us go back to the picture. So now look at this here. Integer 4 bytes of length of block is shown here. Integer again 4 bytes of blocks of key shown here, and the rest all is considered to be key byte array and value byte array. Okay, so look at this here, there is a key as well as a value. Okay, so the data format will be like this, and continuously we'll have data entries like this. The sequence reader and the sequence writer, or sequential reader and writer classes, are designed to read and write in this format by transparently handling the file format information and translating key and value instances to and from their binary representation. So all these are implemented using .NET built-in types library. So all are implemented. So built-in types are supported, .NET, C.NET. The one done call on done callback checks to see whether the application has been terminated successfully or not. So it is something like on completion callback. There is a function called on done or on complete that will verify whether the function terminated properly or the application executed completed its execution successfully or not. If there are no errors, it iterates over the result files downloaded in the workspace output directory. So after the execution of your function as well as application, MapReduce application, then the file will be loaded or downloaded into the output directory. By default, the files are saved in the output directory of the workspace directory. For each of these result files, it opens a zip reader instance on it and dumps the content of the key value pair into a text file, which can be opened by any text editor. So let us see some implementations also. MapReduce is a very useful model for processing large quantities of data, which in many cases are maintained in a semi-structured form, such as log files and web pages. As you know already, we have already discussed this in previous sessions, like the data in the form of Facebook data, Twitter data, or any other web data, which will be in the form of weblogs or web pages. These are semi-structured, sometimes unstructured data also. All these need to be processed properly. To demonstrate how to program real applications in MapReduce, we take a simple log parsing application, because we have seen word count application in the previous implementation. Now here we are taking log parsing for understanding MapReduce function. The MapReduce application has been developed to process a log produced by Aneka container in order to extract some summary information about the behavior of the cloud. So log files are the input to Aneka container, and Aneka container will be the input to our application. Application will be handled like this, and it will be executed. The large data will be segregated into pieces, and that will be sent back after the reduction process executed. So here is a skeleton. These are all just skeleton program, not actual implementation shown here, just to understand how reading operation performed, how writing operation performed, how to define a class, which are the functionalities of the class has been shown here. Sequence reader, this class implements a file reader for the sequence file, which is a standard file split used by MapReduce.NET function to store a partition of the file fixed as data file. This class provides an interface for exposing the content of a file split as an enumeration of key value pairs, and offers facilities for both accessing key as well as values as objects and their corresponding binary values. Okay, sequence reader is shown. It creates interface, attaches to it in the given file. This constructor initializes the instance with the default value for internal buffers and does not set any information about the type of the key and the value, because key and the value can come in any fashion, which we have seen either in the numerical value or a character value can come, either in, even you can think of integer and float values also can be implemented here. So sequence reader instance attaches to it the given file and sets the internal buffer size to buffer size. Maximum buffer size can be set. This constructor does not provide any information about the type of the key value and values, keys as well as values read from the file. So there is a sequence reader, again sequence reader with a buffer size is shown, which the file name is given as a file pointer here. It is also creating an instance of the sequence reader attached to it, provides a key value type. Sequence reader is shown here. Again, there are multiple key types value type is also shown here. Look at it, it's a overriding of data, a sequence reader, which you already know how to override data with respect to input values. Here it is only buffer size. Here file key type value type, file key type value type, and the buffer size. So different type of sequence readers have been defined here as an interface. It's a skeleton program. So set type is also defined here, which checks there is another record in the data file moves to the current file pointer to its beginning. So checks whether there is another record in the data file and moves to the next to the beginning of the next file. Gets the hex next is another function which verifies, gets an object instance corresponding to the next key in the data file. Next key, next value as well as next key also is shown here. again the next value. So once it is, you have a next value as well as next key as well as corresponding hex value for that key as well as value. So again, next raw key, next raw value also are two more functions which are defined to get the raw bytes of the data contained in the file. As either it is in the form of a value as well as a key which will be read in. Okay, so current position, stream length, and seek are again functionalities which we have already said. You need to go to the location of the file. You need to get to the current position of the file. Then you can start reading the data from that file. So these functions will be used to do file operations. Actually, here stream length will get you the exact size of the stream length so that you can verify until that point. Seek is again another function, sequence read instance, and releases all the resources that have been allocated to read from the file. So seeking the information about the file. Similarly, sequence writer is a public class defined here. This class implements a file writer for the sequence file, which is a standard file split used by MapReduce.net to store a partition of a fixed size data file. This class provides an interface to add sequence of key value pairs incrementally. So one we have defined a reader, this one is a writer. So sequence reader will read from the file, writer will create new file which you can call it as intermediate file from the output of MapReduce. So similarly here again, so append is, see when you are thinking about a writing file, so always append function is there. You can recall there is a function or the command which is available in Unix to append the data till the end of the file. So it will go to the end of the file to read information, write information onto the file created. Similarly, append raw, which will append in the raw mode, raw file data. So append raw is again a raw internal buffer will be taken as a raw data. Here also key value pair to the data file split is written with a append raw as well as append raw. Again here key position, key length, value position, and value length also have been defined. So here we have overriding the append raw function with different types of values which is sent to the function. So other functions are also defined to get the length of the file, to close the file, all let us see now. Okay, so using these functions we can do a parsing of log files, which has been implemented here in 3.2.1, that is 8.3.2.1. You can refer to 8.44 page number in the regular textbook for better understanding of this. Aneka components, daemons, container instances, and services which are produce a lot of information that is stored in the form of log files. The most relevant information is stored in the container instance logs, which store the information about the applications that are executed on the cloud. In this example, we parse these logs to extract useful information about the execution of applications and the usage of services in the cloud. The entire framework leverages the log4net library for collecting and storing the log information. In Aneka containers, the system is configured to produce the log file that is partitioned into chunks every time the container instance restarts. Moreover, the information contained in the log file can be customized in its appearance, which is also shown in the form of currently the default layout is the following: dd, mm, yy, the date, time, and level as well as message also shown here. Okay. For example, 15th March 2011, 10:30:07 debug scheduler service, handle submit application scheduler service, like that. Information is available that will be parsed by the Aneka implementation. The possible information that we might want to extract from the same such logs is the following: the distribution of log message according to the level, the distribution log message according to the components, distribution of log messages according to time and date. Also, sometimes you take a log file of Unix file server, file system, then who has intruded our server can also be verified with a system log. At that time, we need to get some time also, at what time people have tried to access our server, try to access our root login with possible passwords, maybe password estimates also can be seen. So at that time, we may need to have some date and time values also. Okay. There are some examples shown here, which I was mentioning: debug, info, as well as algorithm base, add task, adding one task, algorithm base, file, position, provision resources, provision, scheduler service, scanning, candidate storage. So all these things are very, very important. You can see these are the information which has been taken by the Aneka log only. Aneka log only, which is the execution log or the scheduling log, which has been done for Aneka cloud only. Possible information we may need to extract from log is according to the level or according to the component. This information can be easily extracted and composed into a single view by creating mapper task that count the occurrences of log levels and component names, emit one simple key value pair in the form of level name as well as one level name, maybe 10, component name, which is one. Maybe you can have multiple component names with similar components are called again and again. Maybe similar component name is occurred multiple times, then the number will be increased. So this is what we have discussed in MapReduce algorithm. So you need to send enormous amount of data, and then it will give you as per your key value pair. Okay, the reduce task will simply sum up all the key value pairs having the same key. For example, the structure of the map reduce function will be of this range, that is map long, it's a long type, it's a string, 5, which is a string long type, reduce a string long type, which is also taken into string long type. So there is need to be seen, it is not 5, it is a arrow mark. It should be corrected. We will see that. Okay. So thank you very much for listening to me. We shall go to question answering session after this. Thank you all.